This video is an introduction to Chapter 11. It's a short video to explain the difference between the three types of tests you'll do. So you have your note sheets out. 11.1 is going to be about, instead of doing one samples, Chapter 11 is about doing two samples. The first type is called independent sampling. Independent samples, we're going to compare the proportions of two groups against each other. I'll show you an example. 11.2 is when we compare the mean values between two dependent samples, and that's usually referred to matched pair data. And then 11.3 is going to be comparing the population means between independent samples, samples that are not related to each other. Directly related to each other, where the choice of one sample is not dependent on the other one. So those are called independent. This is what it looks like. There are three specific examples. You don't have a paper for that, so we're just gonna, if you're listening to this video, then you're interested in the chapter. So here are three specific examples. This one, the first one is from 11.1, and this is inferences about two proportions. 11.2 is inferences about two means, but the key is that it's a matched pairs design. And then 11.3 is inferences about two means, but the samples are independent. So this is what we're looking at here. So looking at these examples, or the first one, matching two proportions, how do we know what test would conduct? Do people have different spending habits depending on the type of money they have? 89 undergraduates were randomly assigned to two groups and were given a choice of keeping money or buying gums or mints. The claim is that large money in large denominations is less likely to be spent relative to equivalent amounts in smaller denominations. Let's test that claim. So we're looking at what proportion of people spent money, depending upon if I give you basically coins or do I give you large bills. What group of people spends their money more often? That's what we're doing. This is not the formal examples, but just to show you what I'm talking about. You would have a null hypothesis and an alternative. You always need to set that up. In this case, we're comparing the two groups. The null hypothesis is that the proportion, the first group would be equal to the second group. And the claim is that money in larger denominations is less likely to spend relative to equivalent amounts in smaller denominations. And so in this case, I'm going to use letters here. The proportion for the larger is equal to the smaller. And then what we're saying here, the proportion of the larger group is smaller than the proportion of the smaller group. And so that would be the null and alternative. And once you set that up, then of course, we would take care of that in StatCrunch, set it up, and you could run the test. We're comparing two proportions here, two groups, two samples. The second example, matched pair. Use sample data below with a significance of test, a level of 0.05 to test the claim that the population of heights of presidents and their main opponents, the differences have a mean greater than 0. So this is now comparing presidents against their opponents, and that their heights, the heights that of the presidents versus their opponents, is the difference between their heights is greater than 0. So we're actually comparing the two, you're matching up the president with its opponent. And what we're comparing in this case, we're saying that the mean differences between the opponent and the D is equal to the president minus the subtract the opponent. So it's really, let me rewrite that. It's really P minus president minus the opponent. And so you're comparing, you're checking to see is the president taller than the opponent. That's how you check to see by subtracting. And then we're saying the difference is greater than 0, which means this means there the president is taller. That's what that would mean there. And you would have set that hypothesis, and that's the way it looks on StatCrunch. And then on the third type of problem we're doing is called inferences about two means independent, that the groups are not related, the samples are not related to each other, just like here the opponent and president are matched up together. Here, researchers conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects were given a blue background or were given the same task. So there's a hypothesis that somehow the colors can affect someone's creativity. Researchers make the claim that blue enhances performance on creative tasks, on a creative task. So in this case, the null hypothesis, which again, no effect, means that the mean for blue would be equal to the mean for red, their level of creativity, versus the mean values of blue, the claim that the blue enhances, which means that blue's creative performance is greater than red. And so this is the way these are going to look. There are two samples. Here we compare the two proportions. Here we subtract the two values and find the mean difference between them. Here we're actually subtracting the mean differences between the two independent groups. The ones who got blue and red are not related. Here the president and the opponent are related, since that's called dependent matched pairs. That's the introduction for chapter 11. We'll go ahead and do the notes now.